Okay, now we're taking up with part 2 of chapter 5 measurement for Math 107. It's page 51 of your workbook. So one thing I want to go over is you should be reading these, boxes with the definitions. Hopefully you've looked at your textbook as well to get some of the gist. I'm not going to read through all of this for you. This is just here for your reference. You should be pretty familiar with some measurement things, but often we either haven't learned or haven't used the dimensional analysis very frequently. And that's going to be really helpful for our problem solving unit. So I want to go through that. So the equivalencies we're going to use here for weight is 1 pound equals 16 ounces. You could write it as your unit fraction as described before. With the measurement, it's the same idea, same process. It's just different equivalencies. 2,000 pounds equals 1 ton. That's another common one. So we're just going to go through the problems here, and you can pause. You could probably do some of these just on your own and get the problems completed. However, I do want you to try using the dimensional analysis approach. So let me have that show. So convert the following units as stated. So remember, we're going to put the given info over 1. So 72 ounces. And I do want to write the units there as well. So I'm tracking them. You can also write ounces like this. Just like that, OZ. And then over 1. And then you're going to multiply it by the unit fraction that will get you over to pounds. So I want to get rid of ounces. So that's going to go on in the denominator. Remember, this is the opposite method that you're going to use if you have done proportions before. It's different. For unit analysis, we want our units on the crisscross to get rid of them. Whereas proportions, we always want our units consistently in the same spot. So we want to be left with pounds, so that's going to go here. And a lot of times instead of writing out pounds, we write LB. And we are looking at the conversion here, 1 pound to 16 ounces. So you don't have to really even think about like heavy to light, light to heavy. Just know what you're given, what you're trying to get to, and write out the units here as I did, and that'll dictate how you set it up. So I know 1 pound to 16 ounces. Okay. And that so happens I am going from a lighter, or I don't like that light to heavy units, but think of it as it's a smaller increment. So describing the same amount of weight really. And so it is, let's get rid of that. So you're going to have actually a smaller number of the larger unit there. So when we go ahead and do this, we're just going to multiply across the top. But first we're going to reduce out our units there. So we would end up with 72 pounds divided by 16, and calculate that out. We get 4.5 pounds. So we should have a smaller number of pounds than we did ounces to cover that same, or be equivalent to that same weight. So that would be your answer there. So B is very similar. So if you go ahead and try that one as classwork, and C is also you probably could do as well. And I will write out the answers for you, and you can check back. I'm going to pause so you won't see it in live action. Okay, for B, we end up with 3 1/4 tons, or 3.25 you could write it as. So that one you can just look and make sure that you're good to go. For the other one though, I actually stopped there because we need to go across a little bit further in order to get from tons to ounces. So we're going to have to use both of these conversions. We did one similar in the with the length. So I can't just go from tons to ounces, but I can go tons to pounds. and then I can go pounds to ounces. So I set up my units so I know that they're all going to cross out the way I want to, and I'm going to be left with the ounces. So I do that first, and then I fill in my equivalencies from up here. So the first one I have 1 pound and 16 ounces. I could fill that in, but actually I'm going to start here. 2,000 pounds to 1 ton, and then I have my 16 ounces to 1 pound. Okay, and then make sure you see that these are all, that reduces all out, leaving me with just the ounces, which is what I want. So I multiply across 115 times 2,000 times 16, and then I have my ounces there as well, and that all ends up being over 1. There's nothing left down there, and my answer comes out pretty big. 3,680,000 ounces. So I hope that helps. And if you're cruising through these and you've just had this recently, then, go for it. You can try them, but do make sure you come back and check your answers. So when you're submitting the work, it should look like it does on my screen. Even if for the classwork, so you're going to be doing them on your own, but you're going to be checking, like you might say, okay, yeah, I got that one right. I got that one right. So I know that you actually looked at it. Is helpful to me. Same with your homework. When you do any kind of paper homework or activities or things like that, where you're given a key, you're not always given a key, but that you've kind of checked through and looked at it and made sure, especially for like classwork kind of things. Because I just give you credit for making sure it's there, but I'm trusting that you're going to check if it's right, especially if you just worked on the whole entire thing and then decided to check it, like even the examples and stuff. Be careful with that, though. If you're skipping through the examples, you may actually not get all the concept info unless you're reading the book carefully. Okay, one more here before we go into capacity. So we have another weight one. The post office charges 44 cents to mail an item that weighs an ounce or less. So we're on page 52 now. The charge for each additional ounce or fraction of an ounce of weight is 17 cents. At this rate, how much will it cost to mail a package that weighs 2 pounds and 3 ounces? So I think the easiest thing to do is just get everything into ounces. Get that 2 pounds and 3 ounces into just total ounces, and then you can figure it out from there, because all this is given related to ounces, right? For each additional ounce. Okay, or part of an ounce. So to do that, we would have our 2 pounds and convert that to ounces. I mean, you could do that in your head. I mean, some of these things, it's pretty obvious. So I'll let you use your judgment with that. This is a multi-step problem. So you can think of it that way. Like, if you can just jump right here to 32 ounces. But then don't forget to add on the other 3 ounces here. So altogether, our package is 35 ounces total. Okay, and then we're gonna have to set that up. We have like a fixed cost of 44 cents just to mail anything. And then we're going to do our cost per ounce would be 0.17 times the 35. But we actually already accounted for our first ounce. So we are only going to have 34. So it's 44 cents for 1 ounce or less. So we could even write it like this, just to be really clear. 44 cents for 1 ounce. Okay, then you get a reduced rate for all the other ounces used up. So that makes 35 total. Just to be doubly clear on that. And then watch your order of operations, and you're going to get in there, that comes out to $5.78. And then add that to your 44 cents. It'll be $6.22. Make sure you put your dollar sign. It's dollars and cents, so make sure you go to the nearest hundredth. And then give it some context because it's a word problem. So you want to answer in a sentence with meaning and context wherever applicable. So total mailing cost. Doesn't have to be like fancy or anything. But make sure we have some meaning wrapped around that interpretation. So we know you're go back and what was the question? Did you answer it? And does it all line up? And look for reasonableness. Does that make sense? If I got like 0.622 by some reason, like that wouldn't make sense because that would be even less than it is for 1 ounce. So obviously it's going to be more. But if I ended up with like $62, that's not that big of a package. I have to know my decimals a little bit off somewhere. Something happened, or a big temptation people have is like to do this first before they multiply, like not following the proper order of operations. It's kind of easy to do sometimes, especially if you're just working quickly. So watch for those things. All right, so that's it for the weight portion. That was part 2. Part 3 we'll do capacity in a different video. Have a great day.